Alright, this is January 2015, question 10a, and the question says, on the diagram below, not drawn to scale, RQ is 9 meters, RS is 12 meters, ST is 13 meters, angle QRS is 60 degrees, and angle SQT is equal to 40 degrees. Calculate correct one decimal place I, the length of QS. Alright, first thing, to find QS, I'm going to have to use information from triangle QRS. Now, in first of all, triangle QRS is a non-right angle triangle, and the tools for solving the non-right angle triangle are sine rule and the cosine rule. So we're asked to find QS. I'm going to call it X. Alright, so for this triangle, what I have is the information I have what? Two sides and the inclusive angles. I have two sides and the inclusive angle. And if I have two sides and the inclusive angle of a non-right angle triangle, and I wish to find the third side, it is a condition for applying cosine rule. Now, cosine rule says a squared is equal to b squared plus c squared minus 2bc cosine a. So for the cosine rule formula, a is the side that is opposite the inclusive angle. B and C are the two sides of known lengths. And A is the inclusive angle. Alright, so I could say that this is B, this is C, this is little a, and the angle here, the 60 degrees, from my formula is big A. So from the formula, B and C are the two sides of known length, 9 and 12. A is the side opposite the inclusive angle. The inclusive angle is 60 degrees, and the side opposite the inclusive angle is QS, which I call X. So applying the cosine rule, I'm going to have a squared, which is x squared, is equal to 9 squared plus, sorry, that should be 12 squared, minus 2 times 9 times 12, the cosine of a, which is 60 degrees. This is 81 plus 144 minus 180, the cosine of 60. Alright, 81 plus so that's 81 plus 144. I have 225. So this is 225 minus 180 cosine 60, and this is x squared. The opposite of square is square root. So therefore x, which is qs, is equal to the square root of 225 minus 180 cosine 60. Alright, and this would be equal to This is equal to 17.7 meters. So QS is 17.7 meters. Let's double check to be 100% sure. Alright, so correction, the answer is 13.4. The answer is 13.4 meters. So QS is 13.4 meters. The second thing we're asked to do is we're asked to calculate the size or the measure of angle QTS. So let's identify which angle we're asked to calculate. Angle QTS, we're being asked to calculate this angle here. Alright, I'm going to call it theta. We just calculated this to be 13.4 meters. Alright, so now to the right, to find that angle, I'm going to use the triangle to the right. For the triangle on the right, I now know the length of two sides and one angle. And if I know two sides of a non-right angle triangle and one angle, and I wish to find the size of a second angle, I must use the sine rule. Alright, so I have two sides and a non-inclusive angle. Two sides and a non-inclusive angle is a condition for applying the sine rule. Whenever I use the sine rule, whatever I want, I always start with it. So since I want theta, I'm going to say the sine of theta over the side that is opposite from theta, which is 13.4, is equal to the sine of the sine of 40 over 13. So that's equal to the sine of 40 over 13. Alright, I'm going to bring this across here. So I'm going to have sine theta is equal to 13.4 sine 40 over 13. Alright, I'm going to work that out to 3 decimal places. So I have 13.4 sine 40 divided by 13. Alright, so this is 0.662, sorry, 3 to 3 decimal places. And if I know the sine of an angle, to find the angle, I must use sine inverse. So theta would be equal to sine inverse 0.663. So theta, which is angle theta, which is angle QTS, angle QTS is equal to, so I have shift sine 0.663. The angle is 41.5 degrees. So that angle is 41.5 degrees. Alright, next I'm asked to calculate the area of triangle QRS. The area of triangle QRS. Alright, so let's just go back up to our diagram to see which triangle they're asking us to find the area of. They want to find the area of triangle QRS. Alright, so QRS is this triangle over here. I want us to find the area of that triangle. I know the length of two sides. It's a non-right angle triangle. And I know the length of two sides and the inclusive angle. So the area of triangle QRS, the area is equal to a half AB sine C, which is equal to a half times 9 times 12 times the sine of 60 degrees. 60 degrees. Alright, so this a half of this is a half of 12 is 6. So this is 54 sine 60. So this is 54 sine 60, which is equal to this is equal to 46.8, 46.8, and that is meters square. 46.8 meters square. And the absolute last thing we're asked to do is we're asked to determine the perpendicular distance from Q to RS. So IV, we're being asked to determine the perpendicular distance from Q to RS. So let's go back to our diagram to get a visual of what we're being asked to do. Alright, we're asked to find the perpendicular distance from Q to RS. Alright, Q is here, RS is here, so I'm going to drop a line here. Alright, so I'm going to say that this line is at right angles to RS. So let's call this point U. So the length of what QU is at right angles to RS. So therefore the length of QU would be the perpendicular distance from Q to RS. I'm going to call that length Y. Alright, so Y is opposite to the 60 degrees, and the 9 meters is the hypotenuse. So this is the hypotenuse, and the trig ratio that includes opposite and hypotenuse is sine. So I'm going to say the sine of 60 is equal to opposite y over 9. Put the sine 60 over 1, and if I have one fraction is equal to one fraction, I'm going to cross multiply. So y would be equal to 9 multiplied by the sine of 60. So y, which is QU, which is the perpendicular distance from Q to RS, would be equal to, so it's 9 times the sine of 60. Alright, and 9 sine 60 would be 7.8. So this is 7.8 meters to 1 dp. That is to 1 decimal place. Alright.